Today we're going to go through the notes for section 2.3, Properties of Special Parallelograms. Here we go. Our objectives today are to learn the definitions of rhombuses, rectangles, and squares, to learn the properties of the angle, sides, and diagonals of the special parallelograms, and to solve problems with special parallelograms in the coordinate plane. So we're going to start with a quick review of the definition of a parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. And I mark parallel with little arrows, so those two sides are parallel, and then the horizontal sides are also parallel. I'll use a different arrow marking, a double arrow, to indicate the two different pairs. And then in our last several sections, what we looked at was the idea that opposite sides are congruent, so I'm marking that, and opposite angles are congruent. Finally, we looked at a property of the diagonals of a parallelogram. So if I sketch a parallelogram here, there we go. And then if I draw in the diagonals go between two non-consecutive vertices, in other words, two vertices that are not next to each other. These diagonals bisect each other. So this segment is congruent to that segment, and this segment is congruent to that one. Okay, so let's jump right into some special quadrilaterals. First, a rhombus is a parallelogram with four congruent sides. So if I were to sketch a picture of a rhombus, it would have all four sides the same, like that. A rectangle is a parallelogram with four right angles. If I were to sketch a rectangle, I would draw a quadrilateral with four right angles, or four 90-degree angles. And a square is a regular parallelogram. It has four congruent sides and four right angles. So if I were to sketch a square, I would draw a figure, a familiar figure, with four sides of equal length and four right angles. And the square is kind of magic because the square, there's our square, is both a rectangle and a rhombus. It's a rectangle because of its right angles, and it's a rhombus because of its sides of equal length. So as we come down to the middle of the page, we have some different quadrilaterals that we're going to label. And the first one is just our standard parallelogram. And I know it's a parallelogram because of these arrow markings showing me that the opposite sides are parallel. The next figure is a square. And I know that because I can see the markings showing all the sides are equal and that all the angles are right angles. The next figure is a rhombus. And I know that because all of the sides are the same length. Next, we have another square. Next, we have a rectangle. I know it's a rectangle because it's got four right angles. And the last figure is also a rectangle. Okay, so next we're going to look at some properties of rhombuses. And the first property is that a parallelogram is a rhombus if and only if its diagonals are perpendicular. In other words, all of these angles in the center here are right angles. And really what we see is that we've got side, angle, side, triangle congruent. So all four of these triangles are congruent. And again, they're congruent by, let me pick a different color here. They are congruent by side, angle, side congruence. And since all of those triangles, these four triangles, the ones I marked in green, are the same size and the same shape, they have to be right. Those 4 angles in the center there, they add up to 360 and they're all the same. And so the only possibility is that they are 90 degrees. So I'm going to try to write this out in a way that makes sense. So let's think of when we draw a rhombus and its diagonals, we create 4 congruent triangles, 4 congruent right triangles. We actually did an activity in class where we created a rhombus by folding paper, and that really helped us see these properties. So again, please think of all of these triangles. There's one of them. Think of all of them as being congruent triangles, and since they are congruent, these 4 angles, 360 divided by 4 gives me 90 degrees. Those angles all must be 90-degree angles. Let's look at another property of parallelograms. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So let's look at these words here. Okay, this is a parallelogram. Oops. We're working with a rhombus, a parallelogram that is a rhombus, so I can see here that all of these sides are the same. And I'm thinking still about the fact that these 4 triangles are congruent. A diagonal, let's remind ourselves what that is. Diagonal goes across the center, connecting 2 non-consecutive, or connecting 2 points that are not next to each other. So like point B and point D are not next to each other. So the connecting line is a diagonal. And the next word we want to think about is opposite angles. So angle B, this whole angle here, and angle D are opposite angles. And what they're telling us is that this diagonal BD, cuts those 2 angles in half so that this angle right here, that angle that I just marked, I would call angle ABD, is the same as this angle here, and that angle that I just marked, I would call CBD. So again, that diagonal cut it in half so that those 2 angles are the same. There's another pair of opposite angles, and that's angle C and angle A. And those are cut in half by their diagonal as well. So BAC and DAC are the same, and BCA and DCA are the same. Again, we can think about why this must be true, and it must be true because, again, we've got these 4 congruent triangles. These 4 triangles are the same, so therefore, these reflected angles must be the same. Okay, rectangles have a special property. So now we're shifting gears away from rhombuses to rectangles. And again, a rectangle is a figure that has 4 right angles. Rectangle has the property that its diagonals are congruent. So when I draw this diagonal, the purple diagonal, it's going to be equal in length to the other purple diagonal. I could get out a ruler and measure that. But I also could just think again about triangles. So let's for a moment, let me make this a bit smaller. Let's think about this triangle. I'll color in a triangle pink. And let's think about the sides of that triangle, A, B, and C. And it's a right triangle, so we know that A squared plus B squared equals C squared. Now let's look at another triangle created on this figure. So let's look at this triangle. So that triangle has side A here. We've got side B, the same side. And then we're using the other diagonal, C. So again, A squared plus B squared equals C squared. So these two diagonals, this one, the one that slants up, and this one, the one that slants down, they must be the same. And again, it has to do with congruent triangles. The pink triangle I shaded in and the blue triangle I shaded in are congruent, so their hypotenuses are congruent. Let's do some example problems to apply this. Example 1, decide whether the figure with vertices A, B, C, and D is a rectangle, rhombus, or square. Okay, so we're going to start by plotting the points. So I'll start with A, -2, 6. B is 6, 8. C is 4, 0. And D is -4, -2. And I'm going to draw in the lines so I can really see this thing. And right off the bat, looking at it, again, my choices are rectangle, rhombus, and square. Now, just by looking, I can see that these angles are not 90-degree angles, which means this figure is not a rectangle and it's not a square. So it's probably a rhombus, but I'm going to check. So what I'm going to do is I'm going to figure out the lengths of the sides. And to do that, I'm going to use the Pythagorean theorem. So this triangle that I've created down here has one side that is 2 units long, and it has another side that is 1, 2, 3, 4, 5, 6, 7, 8 units long. And I'm going to find the hypotenuse. So I'm going to say 8 squared plus 2 squared equals C squared. So 64 plus 4 equals C squared. So C is the square root of 68, and I'm actually going to leave my answer like that. The square root of 68 is this length here. We could change it into a decimal if we like. But check this out. I'm going to go to another side. And what am I going to notice? Look at when I go to AD. I'm going to draw in a triangle again. And look at the dimensions. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units. And this is 2 units. So we really have the same triangle here, which means the length is the same. The length of AD is the square root of 68. So we just figured out AD is the same as CD. And I'm going to keep going. I'm going to draw in a right triangle for AB. And once again, it's 8 and 2. And then finally for BC, and I'll see the same thing, 8 and 2. So all 4 of these, using the Pythagorean theorem, I can show that all 4 sides of this are the same. So therefore, this thing is definitely a rhombus. Okay, example 2, let's work with some angles. I'm going to zoom in here. Find the missing angles in the rhombus. So a rhombus is a parallelogram. I know this is a rhombus. It's marked as such. We learned earlier in this lesson that the central angles, the angles that go around this, where the diagonals intersect, all of those angles are 90-degree angles. So I could say the measure of angle 1 equals the measure of angle 2 equals the measure of angle 3 equals the measure of angle 4 equals 90 degrees. They're all the same. Another thing then I can figure out is that if this angle here, this little piece of angle C is 25 degrees, then I know what angle 6 must be. Because I know that 90, here we go. I know that 90 plus 25 plus this angle 6 has to make 180. So 90 plus 25 is 115. So if I subtract 115 from both sides, I will get that the measure of angle 6 is 65. So that's great. Okay, now I'm going to go in the Wayback Machine and think back to first semester of this class. So I'm going to draw in some parallel lines, because remember a rhombus is, I'm going to do that one over again. A rhombus is a parallelogram. It's a special parallelogram. And these two lines are parallel. And not only that, they are parallel lines that are cut by, you guessed it, a transversal. So angle 6 is an alternate interior angle with angle 5, which means that angle 5 is also 65 degrees. Another way to think about it is that this top triangle here, again, is congruent to all the other 4 triangles. So if this angle in the corner is 65 degrees, then this corresponding angle down here must be 65 degrees. One more example. Is the figure a rectangle? Why? Okay, so in this case, in this example, we're really just trying to be really careful about language. In order to be a rectangle, we have to know that the thing has 4 right angles. So this first figure, the angles are not given. So even though the sides are given and it looks like a rectangle, we don't know that it is. It could be a parallelogram. It's possible because parallelograms have opposite sides the same. So on this one, we'd say no, or that we're not sure. On the next one, however, we've got 2 pairs of congruent sides, and 1 angle is given. The fact that the sides are congruent tells us that this thing is a parallelogram. That's a property of a parallelogram. All parallelograms have opposite sides, so the 7 and 7 the same, and the 4 and the 4 the same. And since it's a parallelogram with 1 right angle, we know that all the angles are right. We know that they're right because consecutive angles add up to 180. So once I have 1 is 90, I know that the rest must be 90. All right, that concludes this lesson. See Ms. Howell with questions, and you can access the homework on page 393 of the book.